In this video, I'm going to introduce hypotheses, specifically the null hypothesis and the research or alternative hypothesis. What is a hypothesis? You've probably heard the term hypothesis at some point, maybe in a science class, previous statistics course, or just an everyday conversation. Here's the dictionary definition. A supposition or proposed explanation made on the basis of limited evidence as a starting point for further investigation. Think of hypotheses as a starting point. In statistics, we make a hypothesis about the population, hopefully based on previous research or a theory. Then we collect data from a sample, and we use that sample data to determine whether or not there is evidence to support the hypothesis about the population. In statistics, we have two competing hypotheses, the null hypothesis and the research hypothesis. There are some rules guiding how we write these hypotheses. First, hypotheses are always written in terms of population values. If you're using symbols, you would use the Greek symbols that represent population parameters. For example, a mean would be symbolized as the Greek letter mu. The null hypothesis always includes that there is no difference or no change. The word null means nothing or zero. This is often denoted as a capital H with a subscript 0. In terms of symbols, this could include an equals to sign. Some textbooks will also include less than or equal to and greater than or equal to in the null hypothesis. I don't want to get into this in too much detail here, but know that different textbooks have different conventions for writing the null hypothesis. Some will always use equal to, regardless of the direction of the test, and some will use all three depending on the direction of the test. The research or alternative hypothesis always states that there is some difference or change. This could be not equal to, less than, or greater than, depending on how the research question is worded. It's usually denoted as a capital H with a subscript 1 or a subscript A. Let's look at a few examples. On average, students at our university spend more than $100 per term on textbooks. Is this a null or research hypothesis? Recall, the null hypothesis always contains the possibility of an equality, and the research hypothesis always states that there is some difference or some change. The key words here are more than. That signifies a difference. This is an example of a research hypothesis. If I were to write this out using symbols, this is what it would look like. The research hypothesis is that mu, the population mean, is greater than 100. The average SAT math score in the population is 500. Is this a null or research hypothesis? I could write this as mu equals 500. In other words, the population mean equals 500. Because we have an equality in this statement, this has to be a null hypothesis. Recall, the null hypothesis always contains an equality. On average, patients who receive therapy have lower scores on a measure of entitlement than patients who received no treatment. Is this a null or research hypothesis? This time we have two groups, a treatment group and a control group. The treatment group, also known as the experimental group, received the therapy. The control group received no treatment. If the mean of the treatment group is less than the mean of the control group, we could write that as this. Mu, which is the population mean, with a subscript t, denotes the mean of the treatment group. Mu with a subscript c denotes the mean of the control group. This statement does not contain an equality. It communicates a difference. So this is a research hypothesis. Let's do one more, slightly different example. Is the mean IQ score different from 100 in the population? Write the null and research hypotheses. In this example, we're given a research question and we need to translate it into hypotheses. I like to start with writing out what we're given. In this case, is the mean different from 100? This translates to mu, the population mean, does not equal 100. Because this statement contains not equal to, it must be a research hypothesis. Next, I'll write the null hypothesis. The null hypothesis always contains an equality, and it will always contain the same number as the research hypothesis. In this example, our null hypothesis is mu equals 100. As a quick review, hypotheses are always written in terms of population values. The null hypothesis always includes an equality, and the research hypothesis always states that there is some difference or change. In terms of the big picture of inferential statistics, we want to know something about a population. We write hypotheses concerning the population, then we collect data from a sample. We use that sample data to make an inference back to the population.